Good evening, students. And today we are going to see about the fuzzy C-means coding, right? So already I have shared in the YouTube that is the theory part of fuzzy C-means, and I compared with the K-means clustering as well, so that you have a clear idea about it. And now let us see the coding part, right? Okay, so first let us see. Here, what are the different libraries we are going to import? First, NumPy, that is for the numerical Python, and then Pandas for data frame, and then Patplot, lib, and Seaborn for plotting in a graph, and then skfuzzy. So this is the new library. Okay, so that we are going to import. That is, we are using this sklan fuzzy. So that's why skfuzzy as first, that is the alias lab, alias name. Okay, and then sklearn dot pre-processing. So here we are going for standard scalar. So the values will be in different scales. So we have to scale it, okay, according to our requirement. We have to give the range. So for that, we are going to import the standard scalar, right? Okay, so these are the different libraries we are going to first import. After this, we are going to read the data set, that is diabetes.csv. So, as you know, in diabetes, you will have the sugar level and you have different columns. Okay, so to know what are the different columns which is present in diabetes.csv, first we are going to display the first five rows of the data set to know about the data set. Okay, when you just press on here, you can see these are the different column name or the different attributes, that is pregnancies, glucose, blood pressure, skin thickness, insulin, BMI. Okay, so and then diabetes, pedigree function, and then age and outcome. So this is the final one, that is outcome, that is the target, right? Okay, so that is not actually required for clustering, right? Only for classification we need this outcome. So when we are getting the classification, okay, so when you are getting the classification data set, so that is the time this particular outcome or target have to be removed first before going for creating the clusters. Okay, so for that reason only, what we are going to do is after knowing the first five rows of the data set, okay, so we are going to, okay, so we have viewed the first five rows of the data set, right? So that is df dot head, right? So as you know, right, first five rows, if you are just giving head of function, it will take the first five rows, and then you can go for pre-processing. So pre-processing, in which we are going to remove the outcome column completely. That's why we are using the drop in which column outcome, because we don't need the target for clustering, right? Only for classification we need this target, and then we will use this training sub in which we are going to give training and testing, and then the process will be continued when new data enters. So we need the target, but here it is not required, right? And then standardize the data. As I told you, we are using the standard scalar in which all the okay data which is present in the different columns, it should be standard. Okay, so that is, we have to normalize it by using the standard scalar function, right? And then we are using fit transform to df. The complete data frame, all the columns which will be scaled. Okay, for that it will be easy for us to do further analytics and creating the clusters. Now we are going for simply the scatter plot visualization of the raw data. So we are giving the figure size is 8,6. That is okay size, and then we are giving the data scaled, that is between 0 and 1. So that's why we are giving the lower limit and the upper limit 0 to 1. We are going to, okay, so we are going to plot the data points. So we are using the scatter plot. So this is how the output will be. So this is for the first five rows to display as we put head function. And now you can see this is the scatter plot. Okay, so this is the scatter plot of the data points. Okay, so this is how you will get the scatter plot. Okay, and here what we are going to do is after finding this, okay, so we have given the title X label is feature one and feature two. Okay, and then we have displayed also, and then we are going to determine the optical number of clusters. Okay, so we need the best number of clusters using the partition coefficient and classification entropy. So why we are using is partition coefficient. As I told you, the range it is between these zeros and one. If it is closer to zero, then we can say it is a classification entropy is good, and then if it is closer to 1, then we can go for the partition coefficient, right? So likewise, we are having the range in which the lower and upper limit given it as PC and CE, and we are going to, okay, give. Initially, the maximum cluster will be 10, likewise we are given. And then PC values and CE values, we are given it as a null set. So once if you are getting the value, it will be updated. Once if two values which gives the same result, then we are going to end the iteration. Until that time, it is going to continue, right? So after doing all this initialization process, now we are going for the coding part. That is for loop in which I am giving n clusters, okay, in range. So starting is 2 and maximum clusters we are going to identify plus 1. Likewise, we are going for it. So here we are giving the maximum iteration that is 1000 and then initialize as none, okay, and then error is very minimal we are taking. We are taking the error as a very minimal rate, okay. So that is 0.005. Okay, and then we are taking the m values too. Okay, and then we are giving the data scaled. Okay, and then n clusters. How many clusters? Okay, we are going to find out. Okay, so that is also our target, right? So we are using the for loop and we have just given the value to okay display and then compute the partition coefficient and classification entropy. Okay, so how to do this partition coefficient that is np dot sum of u, okay, to the power 2 by u dot shape of 1. So that is highest is better. Okay, so whenever we are going for partition coefficient, we can say it should be closer to 1. As I told you, the range of the value is between 0 and 1. If it is a higher value means we are telling partition coefficient. If it is closer to 0 means we are saying this is classification entropy. Likewise, we are going to find out, okay, to the maximum. In our example, we are going for 10 different clusters in which, okay, how the data points, okay, so we are going to fix in it and we are going to tell always this okay partition coefficient that is PC it should be closer to 1 and classification entropy always closer to 0, that is the lower value, right? And then PC values in which I have to append as initially we are initialized as a null data set and we are going to append one after another. Okay, so we are going to append one after another because we have given iteration as 1000, right? So we have to the process will be continued, okay, until we are getting the optimum result, right? So until that time we are going to do the for loop, okay, and then we are going to plot the PC, okay. So PC and CE only we have found, right? PC that is partition coefficient and the C classification entropy to determine the optimal number of clusters. Okay, we have to know the optimal number of clusters. So here also we are giving the slots. Okay, so that is range as m equal to 2 and maximum cluster plus 1 and then we are giving the base PG values. That is we are identifying the partition coefficient values, right? That is PC values and then okay, so we are going to give it as like a string and then partition coefficient PC, right? And then we are going to set the X label, that is number of clusters, okay? And then Y label is partition coefficient, okay? So color we are giving it as like B. Okay. And then we are giving the axis 2, how to do it with the axis 1 of twin, right? Axis 2 plot, that is range is 2, in which maximum cluster is 1 as usual, and then C values. There we have given PC values, and here we are giving C values. So C values always, okay, so it should be lower. Okay, so lower should be the better. So it is closest to 0 only. Okay, so that is the thing we are going to see in CE, and we are given the label as usual, and then optimal cluster selection using PC and CE. Okay, so this is how we are going to showcase it. Where this is a simple scatter plot of data points. Okay, feature 1 and feature 2 we have given. And in this example, okay, so optimal cluster selection. Okay, so we have selected 10 okay, different data points in which we are going to fix, in which you can see that how the classification entropy, okay, the classification entropy we have identified. Okay, so classification entropy always the range. Okay, so the classification entropy always it is closer to 0 only. Okay, so lower is the better performance. Okay, so likewise we are going to calculate here, and then we have plotted the graph according to the 10 different clusters. Okay, and then according to classification entropy and then partition coefficient, right? Okay, so that is how we have found out for the 10 number of clusters. Okay, so randomly we have to give. That's why we have given init is so when I just look at here, right? So why we have given um, init equal to none? Okay, because randomly we are giving the cluster and we are going to increase the value, okay, of probability, and then we are going to continue the process. Once we are giving this, getting the same result as the previous probability and this one, we are going to fix in it. Okay, we are going to end the program. Okay, until that time, the iteration continues. Okay, so we are going to find the optimal clusters. Okay, so we are going to give optimal clusters in which we are going to choose the optimal number of clusters mainly based on the PC and the CE values we are putting in an okay format, right? One after another. So based on these PC and CE values only, we are going to give the optimal number of clusters. Okay, so after finding it, we are going to apply the fuzzy C means with optimal clusters. Okay, so here we are giving the first cluster, okay, dot C means. So here we are introducing our algorithm C means, and then in which we are giving data scale, that is scaled value, optimal clusters, okay, and then m equal to 2 as initialized, and error is very minimal, and max iteration is 1000. Okay, so that is how we are doing the C means with optimal clusters. Initially, we have just randomly took, and then here we are going to find out the optimal clusters. Okay, so optimal clusters. So here we are going to assign the cluster labels. So based on the maximum membership. Okay, so maximum membership. Based upon that, we are going to apply, assign the cluster. Okay, so for that reason only we are using the cluster labels, which is equal to NP, numpy, okay, dot argmax. Okay, when you are giving the argmax means we can see it is like a maximum membership. Okay, so that's why we are giving argmax of u comma axis equal to 0. Okay. And the next is the plot the final clustering results. Okay. So finally, so as after we modified and then we have changed the value. Okay. Again and again. Initially we took randomly. Okay. So once, as I told you, the two, okay, times the same value repeats, we are going to end the process. So here plotting the final cluster results. So here we are using the plot dot figure of what is the size of the figure, and then for we are using the for loop in which, okay, so we are giving the range as optimal clusters. Okay, so optimal clusters and PLT, that is a plotting dot scatter, in which I have to give the data scaled of cluster labels, which is I and 0. Okay, so we are giving the plot dot scatter, how we are going to plot. So in red, okay, so between 0 and 1, and marker is x. That means what? We are going to find the centroid, that is the distance between the data point and the centroid point in the cluster. Okay, and then give s equal to 200. Okay, so s equal to 200, and then label is centroids. So we are going to give, see, this is the centroid point. You can see, right? The centroid of one particular cluster, and another centroid is belong to the another cluster. Okay, so likewise we are getting the centroid. Okay, so after this we are going to find the, okay, so we have found, okay, the centroid also have been included, and finally we are going for exploring the results for the Tableau visualization. Okay, so that I will deal when I just install the Tableau and we are going to do this. So you can see the two, that is classification entropy. Okay, and then you can see partition coefficient. Okay, so for the 10 different data points, okay, we got the result like this, and this is for the centroid. Okay, for one particular thing and then another particular thing, this is the position which is identified, that is centroid. So in this example we have found only two things. Okay, so that is cluster 1 and 2. So this is for installing, okay, NumPy, Pandas, Matplotlib, Seaborn, Scikit, Fuzzy. Okay, all these things we have to install first. Okay, and then we have to start the process. Then only under this, what are the predefined function, it will work. Otherwise, if you are not importing, installing this, you will not get the final outcome, right? Okay, so I hope you got the clear idea about the fuzzy C means clustering coding. Okay, so we will see with another algorithm with the soon, right? So I hope you was clear with the thing. If you have any doubt in it, you can just put it as you can put it in the chat, okay, so that I can address in the next video, right? I hope you are clear with the idea. Okay, so let us end the session. Thank you.